Hey guys, so let's discuss round number 8, which is called production support. So the scenario is given something like this that okay, checkout success rate suddenly drops from 99.8% to 82%. Okay, let's say this is the problem you're facing. So what is the checkout success rate? So when user is doing let's say final payment, okay, to purchase some item, so at the time of checkout, okay, that time the success rate, okay, this checkout success rate, this drops from 99.8% to 82%, means it is failing somewhere. Okay, so you need to figure out where it is failing and you need to solve this problem. So let's say this is the scenario. Okay, so first of all, we will be seeing answer based on three roles, which is software engineer, senior software engineer, and then principal software engineer. Software engineer is from 3 to 6 years of experience, then 3 to 7 years of experience, then senior software engineer is from 7 to 12 years of experience, and then principal architect or principal engineer or architect level. Okay, so now here, see, this is one of the most important Amazon production support or operational excellence round. Okay, Amazon interviews are evaluating whether you can stay calm during incident. Okay, that is the one thing. Then prioritize customer impact. Okay, that is what they will see. Debug systematically, lead incident responses, restore service quickly, and then learn from failures. So they will evaluate these things, and they're not looking for someone who immediately starts reading the logs. Okay, it's not like you will start reading the log. The first priority is always customer impact and service restoration, then root cause analysis. So it means that first, whatever customer is facing, let's say you have just deployed the new features, okay, and some issue occurs. Okay, so just roll back the deployment so that the customer will have the smooth experience, okay, using the app. And then after that, you do the root cause analysis. Okay, now again, expectation differ by level. So software engineer diagnose and fix production issue. Okay, he will fix the production issue, he will find what was the issue. Senior software engineer, what he will do, lead technical investigation and coordinate teams. Okay, he will start working on the technical investigation, where issue occurs and why. And then principal architect, so what will be his role, means principal software engineer or architect, what will be his role? His role would be derive organization wide incident management, communication, and long term improvements. Okay, so now you need to take care one thing here, you need to just focus this thing: organization wide incident management, okay, then communication to different stakeholders, and long term improvements. Now software engineer, 3 to 6 years of experience. Okay, so what will be the expected answer from him? It would be, my first priority is to understand the customer impact and stabilize the system. Okay, this is what we discussed. He will fix the system first, and I would verify the alert, identify what changed recently, and determine whether the issue affects all the user or a subset of the user. Okay, so first he will concentrate on the alert triggered. Okay, he will check if any alert triggered recently, and then he will check the dashboard. After that, he will check the recent deployments. Okay, anybody have deployed recently, new changes went. And then he will check the application log. After that, then he will check the databases, external dependency, okay, third party API or something is failing, let's say. And then mitigation the issue. Okay, so immediate action from his side would be, first he will verify the alert, check recent deployment, review application log, all the things what we have seen here. Okay, and check database connectivity, verify payment gateway health, and inform senior engineer. So this thing is important: verify payment gateway health. Okay, because at checkout time you are doing payment, right? So you will use the payment gateway service there. Now senior software engineer from 7 to 12 years of experience, what he would be expected to answer is, I would split the response into two parallel tracks. Okay, so first track, restore customer experience as quickly as possible, okay, because of the good user experience. Then investigate the root cause without introducing additional risk. Okay, so two tracks. Now I would immediately assemble the incident bridge. Okay, incident bridge means we'll see here, and assign owner for each subsystem and continuously communicate status. Okay, so his work is to they assign the owner, and then incident bridge, assemble the incident bridge. Now what is incident bridge? So incident bridge is dedicated communication channel like conference call, Zoom team meeting, or Slack channel, okay, that is created immediately when a critical production issue occurs. So he will do coordination there. Now incident response will be something like this. So customer impact, okay, so then what you will do, he will assemble the incident bridge, and there he will assign the owner, okay, to different services. Like for app, he will for application he will assign owner, for DB also, for payment also, for infrastructure also, okay. So now focus area would be customer impact, service restoration. First he will restore the service, old deployment they will roll back, and parallel investigation for the root cause, right? Then clear communication and evidence collection. Now principal engineer or architect, what he would expect to answer is, at this severity I would treat it as a high priority production incident, okay, because customer is impacting. My goal is to rapid service risk recovery while ensuring clear ownership, execute communication, and structured decision making, okay. Now the incident commander coordinates the responses while technical lead investigate independently. So he will assign incident commander here. So now executive communication means keeping senior business leaders informed about a major production incident without overwhelming them with technical details, okay. So he will communicate with the executives. Now and also incident he will assign incident commander, okay. Now enterprise incident flow will be something like this. Alert happen, okay, so incident commander will communicate with this application lead, database lead, payment lead, infrastructure lead, support lead, okay, all the lead peoples, okay. So principles would be restore service first, okay, and then protect customer, minimize risky changes, maintain clear communication, and capture timelines for RCM, root cause analysis. So now follow-up questions, okay, so we will see around 15 follow-up questions here. How many? Let me see. So we have around 14, okay. So let's talk about 14 follow-up questions quickly. It looks like it is a lot, but actually it is not, okay, when you start discussing about these things. So these are very common things, like for example first 5 minutes. So first 5 minutes, what each role will do, okay. So first 5 minutes, what will be the priority for a software engineer? So he will say that my first 5 minutes would focus on understanding the scope and stopping further customer impact, okay. Now steps, so verify alert, check dashboard, okay, identify affected APIs, and then review recent deployments, check infrastructure health. Now what senior software engineer will do first 5 minutes is, I would immediately declare an incident, okay. He will create an incident and then create a communication bridge, okay, will assemble communication bridge, will over Slack or Meet, Google Meet or somewhere, and then assign owners and begin parallel investigation while considering rollback if a recent deployment is implicated. Now architect, what he will do, I would ensure customer facing team are informed, okay, that is the first thing, and then assign an incident commander, prioritize rapid mitigation, and avoid uncoordinated changes that could worsen the situation. So mitigation here means taking immediate action to reduce or eliminate the impact of a problem, even if the actual root cause has not been fixed yet. So this is what he will do. Now follow-up question 2 is related to rollback, okay. So software engineer will say, if a recent deployment is clearly responsible, I would roll back to the last known good version. Senior software engineer will say that rollback should be based on evidence, okay. If metrics deteriorated immediately after deployment and rollback risk is low, I would proceed quickly, okay. And then architect will say that prefer automated rollback through deployment pipeline, okay. Here he is talking about automation through deployment pipeline, not manual rollback, okay. Validate recovery before resuming feature rollouts, right. So let's say you did the rollout, okay, rollback. So now your version is pointing to the earlier one. Then you will verify that everything is working fine or not, okay, everything recover perfectly fine or not, and then you will again do the rollout for the new feature, okay, with some fixes. Now follow 3 is related to database health, Okay, so software engineer will say that he will check CPU, connection, slow queries and logs. What senior software engineer will see related to database, I would examine replication lag. Okay, what is replication lag? So you have created replicas. Okay, so you have write let's say you have write one you updated one record in the database, okay, using write query, so that will get replicated into different replica databases. Okay, so the time it is taking to replicate there, okay, that is called replica lag. So he will examine that replica lag. Okay, then connection pool usage, connection pool related to database, and then query latency and storage health. So replication lag means the delay between when data is written to the primary database and when it appears to the replica database. This is what I just told you. Architect will see that database observability should include capacity trends, okay, failover status, replication health, and automated alerts before saturation occurs. Okay, now so means he's talking here about database observability, what all things he will check in database. So he will check the capacity trends, okay, for the database, and then failover status, replication health, that is the same thing, replica lag, okay, and then automated alerts before saturation occurs, okay, before this problem occurs. Okay, so now follow-up question 4 is related to payment gateway failure. This is the main thing, right? Payment gateway at the time of checkout. So software engineer will say that verify whether payment API calls are failing or timing out. Okay, now senior software engineer will see enable circuit breaker retries with exponential backoff. Okay, exponential backoff we have seen. So every time when you retry after 1 second, he will add some delay so that they will not bombard the server, right? And fail over to secondary payment provider if supported. Now architect will see that critical payment systems should support provider redundancy, okay, graceful degradation, and business defined fallback strategies. So here provider redundancy means using multiple payment provider instead of depending on just one. Okay, let's say you are depending on PayPal, so instead of PayPal just you have different payment providers, so that you will have a fallback strategy, and using that fallback strategy, if PayPal is not working, so request will redirect to different payment provider. So here he is talking about critical payment system should support provider redundancy, okay, multiple payment provider, graceful degradation, right? This one is not working, so just reroute request to another provider, and business defined fallback strategies. Now follow-up 8 is related to queue backlog. Okay, so queue means a messaging queue we are talking here. Okay, and then queue backlog means a growing queue indicates consumers are processing message slower than producer. Okay, so this is your producer, this is your consumer, and this is your queue. So if you are having more values in a queue, it means that producer is producing the messages very fast, okay, and consumer, it is consuming slow. That's why you are getting your queue backlog is increasing, right? So he will see that. Now senior software engineer, what he will see that I would check consumer lag, okay, failed messages, processing latency, and scale consumers if necessary. So he will scale consumers, he will create more consumers here, and then the speed would be faster. Okay, first he will check that why consumer lag is happening. So consumer lag, and then failed messages also, okay, all the failed messages he will check, and then processing latency, why it is taking more time, and then he will scale the consumer if necessary. Architect will say here that prioritize business critical queues. Okay, now you will have a multiple queues here, like payment queue, order queue, inventory queues. So he will first prioritize the business critical queues, okay, which is required for the business first, and then isolate slow consumers. Okay, let's say this consumer is slow, so he will isolate it and then create new one. Okay, after that, and prevent backlog propagation to dependent services. Okay, so backlog propagation means what is that? The spread of queue delay to downstream services. If queue is delaying here, then it means that the other services which is using its output will also get down, right? Other services means downstream services after this service. Now follow-up question 6 is related to thread dump. So software engineer will say that I would capture a thread dump to identify blocked threads. Okay, let's say multiple threads are running and few threads are blocked. Okay, so then that's why it is slow, right? Or if any deadlocks there or excessive waiting time. Okay, so he will capture all these things in a thread dump. So using thread dump, he will come to know all these things. Now senior software engineer will say that compare multiple thread dumps over time to distinguish transient wait from persistent bottlenecks. Okay, so what is this transient waits and persistent bottlenecks? Okay, so it means that analyze thread dump taken at different times to identify threads that remain stuck, okay, real bottleneck, versus those who are on the briefly waiting, okay, temporary delays. So one type of thread is completely stuck and second is just waiting. So he will identify, okay, compare multiple thread dumps and identify these kind of threads. Now architect will say that correlate thread dump analysis with application metrics and tracing before drawing conclusion. So here also he's saying the same thing. Now follow-up question 7 is related to heap dump. What is heap dump? So software engineer will capture a heap dump if memory usage continues growing unexpectedly. Okay, so heap memory, why it is growing. So using heap dump, he will be capturing it. Okay, a heap dump is a snapshot of every stored in a program's memory heap at a particular moment. Okay, snapshot of everything stored in the program memory. Okay, now it helps engineers investigate why an application is consuming too much memory. Okay, so memory related thing you will see using heap dump, and thread related thing thread dump. Now senior software engineer will say that analyze the heap for memory leaks, okay, then excessive object retention, and after that, or cache growth. So what is excessive object retention? This means objects are kept alive longer than necessary even though they are no longer useful. Okay, so these kind of things you will check in that heap dump. And then what architect will see, only capture heap dumps, okay, when operationally safe because they can affect production performance, prefer replicas when possible. Okay, so now follow-up question 8 is related to distributed tracing. Okay, here you're talking about trace ID and span ID. Let's say you have multiple databases and one transaction is saving data in multiple databases. Okay, so you have one request only which is going to multiple databases. Now you don't know where it is failing. Okay, multiple databases, multiple microservices. Now you don't know where in which microservices it is failing. So you have the concept of trace ID and span ID. Trace ID is common for that request, okay, for lifetime end to end. Trace ID will be one, and span ID will be different for different spans, okay, for different microservices. So see, trace is failed checkout request across all services, okay. So software engineer will say that trace a failed checkout request across all the services, okay, for all the services where that checkout request has failed. And then a failed checkout request is simply a customer's attempt to place an order that does not completely successful. Now a senior software engineer will say that use trace ID to locate the request and span ID to identify the slow and failing services. Okay, the same thing what I said. So trace ID means a unique ID that identifies the entire request as it travels across all microservices. Okay, and then span ID, a unique ID that identifies one operation, one service call within that request. So for example, if trace ID is ABC123, then you have different spans, let's say, okay, API gateway, checkout service, payment service, inventory service. So you will have a different span ID there. Now architect will say that tracing should cover every service hope with correlation IDs. So here he is talking about trace ID only, okay, enabling rapid isolation of failure across distributed systems. So now follow-up 8 is related to metrics. So what metrics these different engineers will cover? So software engineer will monitor error rate, latency, CPU and memory. Senior software engineer will monitor request rate, queue lag, database latency, payment failure and cache hit ratio. An architect principal engineer will monitor track 3 categories of metrics. Okay, now he has divided into 3 categories. So the first one is business, second one is system, and third one is infrastructure. Okay, so in business he will check the checkout success rate, okay, like from 99.8 to 82 it has reduced, right? So this thing he will check, and then revenue per minute and order completion rate. Fine. Then in system he will check API latency P50, P95, P99. Means first 50% request, how many time it is taking, okay, and then P95 means first 95% of request, how much time it is taking, and then P99 means 99% of the request, how much time it is taking. Error rates, queue lag, database health, and cache performances. Now in infrastructure he will check CPU, memory, network, disk input output, and auto scaling events. Okay. Now follow-up question 10 is related to customer communication. So software engineer report customer impact to the incident lead. Okay, he will not directly talk to customer, but yeah, incident lead he will inform. Now he will report, and then senior software engineer will provide regular status update to support team so they can respond consistently to customer inquiries. Okay, so senior software engineer will talk to support teams. And architect, so maintain transparent communication with customer support, business stakeholders, and executives. Okay, he will talk with multiple people, including executives, customer support, and business stakeholders. Public status updates should be factual and timely and coordinated, okay, based on facts. Follow-up question 11 is related to incident commander. Okay, so we saw that architect will assign an incident commander. So software engineer, the incident commander, coordinates the responses, while engineer focus on technical investigation. And senior software engineer, the incident commander, assign honors, okay, and tracks progress, remove blockers, and ensure clear communication. And what our architect will say about incident commander: the incident commander should not become primary debugger. Okay, he will not start doing debugging. Their responsibility is coordination, prioritization, communication, and decision making. Okay. Now follow-up question 12 is related to root cause analysis, RCA. So software engineer will say, after recovery I would identify the exact technical cause using logs, metrics, traces, and deployment history. Senior software engineer will say that an RCA should include timeline, okay, root cause, contributing factors, customer impact, resolution, and action items. And architect will say an effective RCA focuses on system improvement rather than individual mistakes. It should identify technical, operational, and process gaps. Okay. So RCA focus on system improvements rather than individual mistakes. You will not start blaming their peoples, right, during the RCA. Now postmortem. So postmortem, so software engineer will include, okay, what happened, why it happened, and fix applied. What fix he has applied. Senior software engineer will also include the detection, okay, response timeline, recovery action, and lesson learned. And what architect will say about postmortem: so postmortem should be blameless. So here again he is saying it should be blameless, actionable, and tracked to completion. Every action item needs an owner, priority, and due date. Okay. Now follow-up question 14th, the last one: prevent recurrence. Okay, so prevent recurrence, software engineer will say that I would add better monitoring so that this thing not happen again. So software engineer will say that I would add better monitoring, automated tests, and alert to detect similar issues earlier. And what senior software engineer will say, I would strengthen deployment safeguards through Canary releases, okay, automated rollbacks, improved health check, and kiosk testing and runbooks. What is Canary deployment here? Canary deployment is a deployment strategy where you release a new version of a small percentage of user first, okay, and then monitor it, and then gradually roll it out everyone if it is stable. Okay, so let's say version 1 is running for 99% users and version 2 will run for 1% user. If it is working fine, then gradually you increase the load there. Principal engineer will say about this prevent recurrence. Okay, he will say that prevention required both technical and operational improvements, right? So like better alerting, automated rollback, circuit breaker, and graceful degradation. Then capacity planning, resilience testing, runbook and training, regular game days, and architecture reviews for critical dependencies. So he will say the objective is not only prevent the same incident but to improve the platform's overall resilience. Okay, so that's it. Thank you.